Let's start Lesson 2, Bipolar Transistors. Let's start Section 2.1, Bipolar Junction Transistor, BJT for short. Assume that there is a silicon base and a small quantity of a group 13 material, for example indium, is doped in the central part, and those of a group 15 material, such as arsenic, are doped into the left and right parts. Then the central part becomes a p-type semiconductor, and the left and the right parts are changed to n-type ones. Then, from left to right, an NP junction and a PN junction are formed. This bipolar junction device is called a bipolar junction transistor, or BJT for short. This is an NPN type BJT. An electrode is attached to each part. These electrodes are called, from left to right, emitter, base, and collector. This is the symbol of NPN transistor. From left to right, the electrodes are emitter, base, and collector. The arrow indicates the direction of current. In the case of NPN transistor, the current flows from the base to the emitter. This is the appearance of a transistor. Its model number is 2N3904, one of the most popular transistors available on the internet. It is an NPN transistor. It has 3 electrodes, from left to right, emitter, base and collector. This is, again, the symbol of NPN transistor. The emitter, base, and collector are in the same order as those in the left photo. There are 2 types of bipolar junction transistors. One is NPN transistor, and the other is PNP transistor. If a group 15 material is doped in the central part, and a group 13 material is doped into the left and right parts, then we have a PNP transistor. The electrodes are, from left to right, emitter, base, and collector. This is the symbol of PNP transistor. The electrodes are in the same order as those in the above transistor model. In the PNP transistor, current flows from the emitter to base. The arrow indicates this direction. This is the appearance of a PNP transistor, 2N3906. Another popular transistor, available on the internet. The electrodes are, from left to right, emitter, base and collector. This is the symbol of PNP transistor. The electrodes, emitter, base, and collector, are in the same alignment sequence as those in the left photo. Let's move on to Section 2.2, Amplification of voltage by BJT circuit. This is an NPN transistor. TR denotes the transistor. C, B, and E denote collector, base, and emitter respectively. We need 2 DC voltage sources for the operation of this transistor. One source VBB is connected between the base and emitter. The other source VCC is connected between the collector and emitter. VBB and VCC must be positive for an NPN transistor. Then we insert an AC voltage source Vs into the base circuit, and a resistor RL in the collector circuit. 2 voltages are defined. One is the voltage VBE across the base and emitter. The other is the voltage VCE between the collector and emitter. We have 3 types of denotations, Vs, VBB, and VBE. Both the script and subscript of Vs are lowercase letters. Vs contains only AC voltage. Those of VBB are uppercase ones. VBB has only DC voltage. In the case the script is lowercase and the subscript is uppercase as VBE, it may contain both DC and AC components. Let's see what this transistor circuit does. These are experimental waveforms of VBE and VCE. The horizontal axis is time, and the vertical axis is voltage. VBE changes little. It contains a small AC component. On the other hand, VCE varies much, its AC component is large. This example shows that this transistor circuit amplifies the very small AC component of VBE, and outputs the amplified AC voltage on VCE. Experiment 2.2. Construct this circuit. Set the signal voltage Vs equals Vm sin omega t, where the amplitude Vm is approximately 10 mV, and the frequency f equals 100 Hz. Set the DC voltage VBB so that the average value of the collector emitter voltage V bar CE equals 3 volts. Measure VCE and the base emitter voltage VBE. This is the result of experiment 2.2. The horizontal axis is time, measured in milliseconds. The vertical axis is voltage, measured in volts. The red line is VCE and the blue line is VBE. The average values V bar CE and V bar BE are the DC components of VCE and VBE respectively. VCEM and VBEM denote the amplitudes of AC components of VCE and VBE respectively. The effective values were measured by ADALM 2000, and VCE was 332 mV and VBE was 6.1 mV. Note that the denotations with uppercase script and lowercase subscript express effective values. This result shows that the transistor amplified the AC component of the input voltage VBE, and the AC component of the output voltage VCE became large. The voltage gain of this circuit is defined as VCE over VBE, and it is denoted by AV. It was 54. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.